All right, so when we just finished there, we'd gone through the qualitative QC features, and now what I would like to do is to look at some of the quantitative ones very quickly. So we looked at the end of the QC. We said that final section beneath the warnings showed this kind of dictionary of useful things from start to finish. So now we're going to go type CD and CD AFNI demos. And then there's a couple directories down, for better or for worse, this directory here. And the name is just there at the top. So it's AFNI demos, AFNI into PEMINC, and AFNI O2 PEMINC. And then you should see this set of stuff when you get there. This is task data from a memory encoding. I forget what the PA part is, but it's a memory encoding task. It's a event-related task design study. And so I just want to show a couple different things using this. All right. So let's see if hopefully everyone's here. If you type ls, there's a command here to open up multiple QC there's a lot of stuff in the file, but it's basically inside is an open APQC command that has in files, but it has actually a set of files that it can open up. There are different ways you can provide it with globs or different things. For now, we're just going to run it. And these are subject directories with text files, and about 10 of them, I think, have QC directories. So what we're doing is we're opening up 10 different subjects, QC all together. So we're going to do that magical step with do 00. Okay, so you can type tcsh do 00 and hit enter. And it's this many QC which I think is about 10. Okay, so hopefully you get this. I will say on Macintosh computers and even some Linux now, what should happen is this should open a new window with then new subtabs in it. I believe on Mac, it won't open necessarily in a new window first, so these tabs just get added or appended to whatever browser tab you have. I apologize for that. At some point, I'll try to figure out how to force that to happen more on Macintosh computers. What you can do is you can have the last tab and hold down Shift in the first tab, so you're kind of selecting all the tabs in between, and then pull that out, that whole collection out of that window into a new window. If that makes any sense as I've described it, I hope. But otherwise, so because what we're going to do now is see some of the features of looking at multiple HTMLs and opening them all up together. I believe this is a slightly older, yeah, this is a slightly older set of HTMLs. And so a couple features aren't here and a couple of the items, like the variance map is not here. We just have to update it, but this will show the main point of what I want to show. So what I want to look at first is I want to click on vorg. And then this, so I'm on my computer, the tabs, as I see them here, are in kind of alphabetical, alphanumeric order. Some browsers will scramble it. I don't know why. I think there's an extension that you can have to put them in order, but for me, this is subject ID with 60,070. I'm just at the first of the list. It's not really important which one's at the first. Um, everything gets everything is saved in the correct spot in that. It's just whether your screen looks exactly like mine. But so I've clicked on Vuorig. Now I can navigate to another tab over by either clicking on it or what I find more convenient, hitting Control Tab. That moves me one tab to the right, control tab again, 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 and control shift tab moves me left. So in this way, now that I have all my tabs in this new independent window here, I can very easily flick through them to see different subjects like this. Now the problem is that here's my data for this subject, it's here for another one, and if I scroll down to something, I'm in a different spot on all of these, and that makes me sad. What should be able to happen on your computer now is if you click any gold text and double click it, 1, 2. Now, if you notice, my page moved up a little bit, and now if I hit Control Tab, if I go across all subjects here, they're all in the same spot. So this image panel is kind of locked in here, and it's just the brains changing. And I can go forward and backward, Control and Control Shift Tab. You'll notice the warns level is changing. Different subjects have I mentioned that different warns, this one has a maximum level of none. This one has a maximum of mild, medium, maybe a severe, and there's no severe here where it's bright red. Okay, but this is the idea that now um, there are two ways you can look at data. You can look at one subject across lots of features or one feature across lots of subjects. And in actuality, when I do QC, I really like to look at one feature across a lot of subjects because my eye is very sensitive to differences and similarities and things like that. And in the same way that when I mark tests or quizzes, I take one question across all subjects or across all students, things like that. It's just easier to kind of look at the same thing repeatedly. If I have any question, I can dive across properties across a subject at the same time, but in this kind of matrix of ways, that's why I think about it. So I can very easily see that all these subjects in their original data have similar tissue contrast, similar field of view, coverage, all sorts of things like this. Okay, so this is okay. Where the rubber really hits the road, I think for me, is with the VE to A, and now I'm going to double click on the gold text. And now if I hit tab and control tab, I can see the quality of EPI anatomical alignment across all my subjects. I can see where the coverage is similar and different. If I always kind of focus on these sagittal slices here, and I can see, some subjects have kind of better coverage, probably in part just by how their head is angled in the scanner. And other ones have, more dropout, like this person has more dropout. Do I really care at this level? But it's something that I'm noticing, or the relative amount of CSF. But I also just get a sense of the general quality of alignment, brain inhomogeneity, all sorts of things like this. And I'm talking a lot more and going through this repeatedly, but if I just open this up, clicked here, and went through it once, I've done quality control on this feature in under 10 seconds because everything is okay here and I know it. If something is wrong, sure, I can take more time on it, but then I need to take more time on it. And that's really kind of how quality control works. We've tried to make the QC efficient and preloaded with so much stuff. So you can just check it, and if things are fine, great, you're not spending a lot of time on it, and now you know. If there is a problem there, you got to spend time on it, and now you know. And so these are the kind of tensions of things. People will always say, well, I have too many subjects, I don't have time to do this. And it's really probably not fair to yourself or your study to say that because there really are things that you can check quickly to be more or less sure of the quality of your data. Okay, and now, if any of these was particularly bad, I could make a comment for one of them or whatever, and it would be saved here, and I go through and maybe that's good or whatever. And all of these are saved in their appropriate QCHTML slot. In this case, I'm just going to clear everything away because those weren't actually meaningful examples, but just to show that can happen. If I need to look at the buttons for any of these, I would click the buttons. Now, in this particular case, in this demo, we've not provided all the data that goes along with these QC directories. So actually, these buttons will not work at the moment. It just won't fire stuff up successfully. In this case, what AFNI is doing is it's loading template data that anyway, it's not it's not correct because we didn't provide the data just to keep this directory and download small. Daniel will walk us through later looking at a set of QCHTMLs where you can click the buttons, but they all work when you have the data available for them. Since each results directory might be over a gigabyte, we didn't want to provide 10 more gigabytes to download, basically. All right, and it was, I can do this for VA to T. And one thing I'll mention is in more modern QCHTMLs, actually double clicking on these tabs up here will lock everything together. Oh, does that exist here? Oh yeah, it is. Oh, I guess it exists here. Okay, this is modern enough that that happens. So if you double click on these tab labels too up at the top, they lock everything together. I thought we hadn't updated since then, but I'm just old and senile, so. Here you go. So now you get a sense of your quality of alignment. These were actually nonlinear alignment, and we're aware there's more and less variability across your subjects. Let's look at the VStat now, and I'm going to double click here. This is our full FStat. Remember what we said, this is where we have quality fitting for our data model. Let's take a look at, I'm going to start back at subject, the first one in my list here, and I see some stuff maybe in visual and maybe a couple things out here. I'm just going to hit Control Tab and walk across my data. That was one loop through. Okay, I'm going to go through again. Look at the different characterizations of data and the different sense I get of the modeling and what was done. Here, for example, I don't see a lot of noise everywhere. Sure, there's eyeballs, but that's fine. I see visual cortex. I see these two things quite brightly. My maximum FStat value is around 30 for this percentile. This looks, very good. This one looks pretty good. These two look pretty similar if I'm going back and forth with tab and control shift tab. This is subject 72 and 73, just giving the last two numbers. Okay. Now, if I go one more, this one is also similar, right? So these three look pretty similar. There's some differences in the upper cortex, but some of the main parts here look similar. And then this looks very noisy. The maximum F-stat is a bit lower. And then I get to this subject 60,078, and it's all over the place. And I can tell by how noisy the background is relative to my maximum here, something is very different here, right? This is why I enjoy seeing all the background stuff because it gives me a sense of the noise floor that I'm fighting with. This is a more subtle event-related task. This isn't just audio visual on off in big blocks. So the results are a little more svelte. For the next subject, things are back, and I get really a sense of my data very quickly about what's expected and what's kind of typical and what is weird and I don't understand. Now, what am I going to do with this subject? Let's take a look at other things. This is this subject 78, basically. Well, I can look at individual stimulus model results here. So this is the control stimulus and the task stimulus, and I'm not seeing a lot of strong effect, maybe some visual, maybe not even, nothing really here. When I come down to motion, there's a fair amount of motion. It's about 24% motion. And I look at this and I think, well, but it's kind of scattered around. So, is it just motion or what? Who knows? And I scroll down here to the individual motion plots. Let me look at the regression QC block. This is my sum of stimuli, and these are my individual stimulus events here. Now, again, this is event-related design now, more realistic than our block design for modern tasks. Do you notice anything about when either the control or task stimulus is on and about my motion censoring? Well, to me, a lot of times when I see this blue peak up, I see a censoring along with it, or the red peaks up. For a lot of them, I strongly suspect that this participant has task stimulus motion. So I think they're pressing a button as part of this task. My guess is the subject is nodding their head pretty strongly or something, some kind of motion when they're pressing the button. And now again, what am I going to do with this information? Do I drop this subject or not? I don't know at this point. That's for you, the researcher, to decide, but I am awfully suspicious of this. And having all this information in one place where I can check it out, I can be looking at the VStat across everyone, see something weird, and now decide, oh, I need to go investigate more. And again, this is my strong suspicion here. It's not just the amount of motion that's problematic, it's when it occurred, it's crushing so much of my task to stimulus design in my regression. I see some weird things as well. I mentioned before you can see weird things in the core brain data set. The residuals after modeling correlate, the average correlates quite strongly everywhere. There's probably still some motion or some other artifact left in the data as well. The TSNR pattern isn't so suspicious here. The max is 170. That's still actually quite high. Notice that TSNR tells me nothing about the quality of performance of the task here. TSNR is okay for some things, but it is not the be all end all of everything. I do have low TSNR in a lot of regions, though. That's worth noting. Um, yeah, these are the anyway, rad core and things. I'm going to come down to the warning section, and it tells me that I have a high amount of warning overall, and I also have a high amount of warning throughout where my each of my tasks is non-zero. All right. So this is a nice lesson, I think, about a couple of things here. The power of using the QCHTML to browse across a subject, a set of subjects, and to be able to check into individual ones for different properties as well. So this subject here, I would come in here, I would come to this section or maybe the regression section, and I would make a comment, task stim motion. And that's probably an X, and I probably would not use this subject. But now I can explain exactly, and I can show to you or anyone else why I can share this QCHTML, and you can see why I dropped this subject. All right. Any questions on this? I'm going to move on to a somewhat different topic. Let's check the chat quickly, I guess. Okay. All right. And I'm going to close this. Also, older versions of AFNI closing this, it would kind of ask you every time you close a tab when something happens. So that should be better now. It should close more quickly. And again, I close all the tabs, and then the server is still running to the terminal. So I Control C to cancel out of that. And now I'm free to type in my tab. All right. Now what I'd like to do is stay in this directory in AFNI open-E global process commands file. All right. Here are things that we can copy and paste in this directory to do a few different tasks related to processing and global in the sense of kind of group level. All right, so what we have in this directory, if I put this aside for a second, is it's as if we have a bunch of subjects of processed data. So let me just show one of them. So the first one in the list here. So this is like you can see what processing was done both from the AFNI proc command. We didn't provide all the data again, just for the amount of stuff and the processing script. And then if you notice, there's a subject ID.results directory. We probably recognize that now as something that maybe Afni Proc created processing our data. And if I list stuff here, the file names look suspiciously like what we just got when we looked at the Sub-Zero subject that we spent the morning processing, except there's no brick files, those large ones that actually have data. These are all just the text files, kind of a subset of the output. So we can still do some stuff with it for illustrative purposes, but we don't take up a huge amount of disk space. Excuse me. The thing that I mostly want to focus on at the moment is one of the files here, this one. This file that is out.ss review, single subject review for a subject ID, I'm just going to cat it. You don't have to do this. I'm just doing this a little bit quickly. This is this same information that I've showed a couple times now and said this is a nice set of summary of background, intro, input data, things that happened while processing, and some summary quantities at the end. And wouldn't it be nice if we could combine all this across subjects? This file exists across all subjects. If I kind of glob out the subject IDs here, this file is included in all these subject output directories. So right now I have 60 subjects and I have all these review text files for all of them. What I can do now is we have in this global process commands, this command here, this gen ss review table, notice how the ss review, just like in the text file that we looked at, this is going to make a table, a spreadsheet, using all those subject text files that we just looked at. It's going to do this thing that I wished we could do earlier, combine them into a spreadsheet. So I'm going to copy this line 26 and line 27 and just paste that into my terminal and execute it. So it's this first genss review table command here. It's just 2 lines long. Okay, it ran. Okay. I left one around. Let me just remove from the last boot camp. I still had one hanging around and it didn't want to overwrite it. There. So you can see when it creates now, it didn't output anything. It didn't whine about a previous one to not overwrite, and it exists. And so now I have my new SS review table, and if I AFNI open that, this AFNI open command will recognize the extension as XLS. If you have something that can open a spreadsheet file, it will open it in spreadsheet. Otherwise, it will just use a text file. So I have LibreOffice on my computer. I'm a big spender. So here we go. So now each of these columns is one of those key values from that text file. And then I have all this information across all subjects. So let's say I go to like max here, average motion per TR. I can look at this and I see what the maximum motion was per TR, or maybe this one is even better here, the number of TRs above the motion limit. I can instantly see, oh, this subject had 29 versus these first ones only had a few. This one had 14, things like that. This one had 69, this one had 93. Some subjects really moved a lot. But now all this information is here in a lovely spreadsheet for me, and I can really check it very quickly. Awesome. Now, wouldn't it be nice if I could automatically search through here for certain things like find all the subjects that have, more than 50 motion events that I censored, more than 50 time points censored, or TSNR. One of the columns in here is average TSNR and things like that. Well, if you can't guess from the tone of my voice, that actually does exist. This next command is something that will not only take all the same in files, but it is going to find any subject who has a certain property, and basically a property that I would want to maybe censor that subject or drop them. So if their censor fraction is more than, greater than, or equal to 0.15, which means it's 15% or more of their time points were censored, I want to have that subject, shown to me. Or if the average amount of censored motion was more than zero point 0.1 millimeters, or if the greatest displacement of any time point was 8 millimeters, like the subject was trying to crawl out of the scanner, I want to know. So let me take that command and go to the terminal and copy paste it. And what I get now is just shown to me instantly in the terminal the list of subjects who had one or more of those properties. So this is my instantaneously, qualitatively, my potential drop list of subjects for very clear reasons, for very quantitative ones, for ones that I can run and again and again and again as I acquire new data or I move to a new data set. I can publish in supplementary tables, etc. These are kind of absolute quantities. We also have ones that are based on z-scores across a distribution of properties. You can do this based on voxel size. You can also ask, did something vary across subjects? So, for example, are you worried that you used different versions of software across subjects and you want to make sure you use the same one? You could do something like, uh, I'm not going to get it exactly right, but it's going to be like AFNI version vary. The amount of work I have to do to get this exactly right is just to actually look at it. Oh, it's actually, wow, look at that. It actually is AFNI version. So I think I could use this command here and run it. So there we go. In my AFNI version column, it tells me that did any of them vary from the first subject that had 24.3.0 run? No, none of them did. So now I know. Okay, so this is very flexible, and you can use a lot of different things here. But this is a really nice thing to do quality control and to complement, not replace, the qualitative one that we looked at. And actually, in the qualitative review table, there was a final button up at the top. When you put your rating in the final button, that actually becomes active to be selected by GenSS review table here, selecting a different infile from the QC directory. So it's a copy of the same ones here for every subject. But now, if you had rated a subject based on the qualitative QC HTML to be dropped, that could also be included in this list automatically. So you can really get your full list of subjects to drop very easily through both qualitative and quantitative criteria. Questions on this? Okay. Now, something else that we've more and more, the longer I've been in this field, the more I work on earlier and earlier stages of processing. When I started, I was actually, my first task as a postdoc was to work on um, what became kind of working on tractography algorithms, so kind of the very end stages of diffusion processing. But then you realize, well, you have to depend on how the tensors were fit, and then you have to depend on how they were acquired, and checking all these processing steps and things like that. And so actually, something that we found to be very important is something like this GenSS review table, but for just the raw unprocessed data to see, are these properties that I have in my data consistent across the group, or are they even what I want across the group? To do that, we have something that's called a getting to know your data command. So to run that, I'm going to leave this directory and actually go back to, so I'm going to cd, let me rearrange my terminal slightly. I'm going to cd to home and then AFNI data 7 again and task demo AP. And so you should see these do scripts that we ran one of before. I'll note that here also the SS Warper command we ran to generate the SS Warper data are here. We even have a free surfer command that ties in with this data for our surface processing. So you can really see how the surface processing that we don't cover, we don't have time in this boot camp. You can see how we do that. Even how we made the timing files is stored here. So you can get that kind of extra information. What I want to look at here is this do01 GTKYD, which stands for getting to know your neighbor uh, data. Oh, no, it's getting to know your data. Sorry, not getting to know your neighbor, getting to know your data. Sorry, it's been a long Wednesday. Getting to know your neighbors is a good thing too, often. But all right. And so what this is actually something that we run really across subjects when we have more than one subject data set, like a whole group worth. At this moment, we only have one subject. So instead of kind of globbing across all subjects, we only have one. But what I'm going to do is I'm going to run this getting to know your data check across all the subjects we have, all their EPIs. Okay. And so actually, yeah, I guess I'm just going to copy paste it, or we could run the script, but I'll copy paste it. And what it did here as a first step is it went through and checked the header information of a lot of all the EPI data sets that we gave it. So a glob across all EPIs, potentially across all subjects, and usually across all subjects. And it created this data summary table. So now if I run AFNI open on this Excel spreadsheet, open it. What I have is for every EPI data set, and what would normally be many more, I have properties like the matrix dimensions, the number of volumes, so like the number of time points, what is the data set orientation, voxel dimensions, TR, so many properties. Do I have slice timing information that's not zero? Um, and then obliquity, the origin value, the datum for if it's a nifty data set, S form and Q form codes, all sorts of useful pieces of information. Are there sidecars? And I can check all this for consistency. And now, if you remember what we did before, this idea of I have a lot of systematic data, I put it in a spreadsheet. Can I check it as well from a command line? Yes, you can. Now we can use GenSS review table. There's nothing special about the output of AFNIPROC other than it created these colon separated files that I could parse. And we can run getting to know your data, run GenSS review table on the getting to know your data stuff. So I can see, does anyone have an AFNI view space that's plus TaylorAC, which I would want to know because my data should be an original space, not a standard space. Maybe I want to know if the voxel dimension, the absolute value of any of the three voxel dimensions, is greater than or equal to 2.8 for whatever reason. Or do my number of volumes vary? So that is, do any of my EPI datasets, are they shorter or longer than any others? When we're comparing floating point values like TR, we can check if they vary plus or minus some amount because you can't check floating point values for equality in a stable way. So these are just here as examples of a few different things you can do. There's more if you look in the help file for this program. I'm going to copy and paste this now here. And actually what we found, I'm going to shrink my terminal slightly so this all fits without wrapping here. Um, my actual output of the command is here. For all these properties, almost no subjects showed up except for this is a voxel dimension greater than or equal to 2.8. Not the X, not the Y, but the Z dimension in these data sets had that property. In reality, is that a problem for me? No, I just made an example where something would show up, and this data is actually pretty reasonable. So there you go. Um, but now you know this command. This is so useful when you download a data set because when I'll talk a little bit briefly about this quality control project we did. The heterogeneity of properties was stunning. The voxel sizes were different. The number of TRs were different. The number of runs were different. It's as if people actually mush together different acquisition runs, different protocols, and that matters when you're processing your data. And it might even be an exclusion criteria, or should I use this data set criteria? This is also useful when you acquire your own data. You can check and see that properties really stay consistent because I can keep running this pair of getting to know your data and GenSS review table every time I add a new subject. And it's a very easy scriptable way to check for consistency. Um, Scanning and acquiring your data is so hard. You have to push buttons, and it's very easy to. I don't mean that facetiously, actually. I really mean it seriously because scanners kind of fight with you about properties, and loading a file, the file names can be pretty awkward, and so you might not get the right one. A version updates on the scanner of software and it changes things entirely. So you really have to stay on top of this by all means. I people who acquire their own data, I have very much respect for because it's a very challenging thing to do consistently. Um, and you can't get back the data once you've acquired it. So you really got to be sure about it. So these kinds of checks are very helpful. So essentially, get GNSS review table when you get raw data and you're before you've done anything, and also after you've processed all your subjects and you want to check things. This idea of systematically checking, we try to put at your fingertips. Any questions on this? All right. I think all the questions seem to have been answered. So let's let's take a 10-minute break now. And if it's all right, I'm going to slightly shorten the break, but I will start the next session to introduce the topic that Daniel is going to talk about, which is some of the QC from the quality control project. And I will just try to go through an overview of that quickly. Is that all right, Daniel?
Sounds good to me.
All right. I got it recorded, so perfect.
What?